All right, let's see what it was that you got. Let's see if you were successful in finding the coordinates of your fractional point, whatever that fraction was supposed to be. So here's the work for 3/8. I was supposed to average together the 1/4 point and the 1/2 point. So here is the 1/4 or the 1/4 formula that we came up with at the beginning of the lesson, and here's the midpoint formula here, adding those two together, dividing by 2. In order to resolve this complex fraction, I multiplied it by a fancy 4/4. Why did I choose 4/4? Well, if I were going to add these two fractions together, I would need to get a common denominator, and between 4 and 2, the least common denominator is 4. So that's why I chose it. When you multiply the 4 times the first fraction, the 4's cancel. Boop. When you multiply the 4 times the second fraction, this 2 divides in this 4, but it still leaves a factor of 2 left over. So let's see how that plays out. When you simplify the first part, it's just the numerator, which is 3x1s and 1x2. But whenever you cancel out a factor of 2, in the 4, you're still left with this 2, that you have to distribute across the top here. So you're going to have 2x1s and 2x2s. Combining your like terms, your x1s, you have a total of 5, and your x2s, you have a total of 3. So here is the partitioning formula, basically, for finding the 3/8 point for both the x-coordinate and the y-coordinate. So let's see if we can summarize our data and also check the work that you did in order to find your fractional point. So I got a series of pictures here for the 1/8 point, the 1/4 point, which I already have the formula down, obviously, the 3/8, 4/8, same thing as a half, 5/8, 6/8, same thing as 3/4, and then finally our 7/8 points. All right, so coming back up here to the 1/8 point, the formula for that should have been 7x1s plus 1x2 divided by 8. And that looks really, really similar to the one that we did for the 1/4 point. Okay, let's look at our 3/8 point, which we just did, is like right there. We have 5x1s plus 3x2s also over 8. There's our midpoint. 5/8 goes like this. 3x1s plus 5x2s over 8. And then we have one more. We have 7/8. So the 7/8 is 1x1 plus 7x2s, all of this over 8. Again, that should be enough evidence that's going to suggest to us, using inductive reasoning, what a formula could be to find the fractional distance, any fraction that we want. So let's see if we can put these pieces to work. Actually, why don't you go ahead and pause right now and see if you can figure out what it is, and then unpause and check to see if your inductive reasoning skills are as sharp as ever. So, okay. Now, let's look at the 1/8 point. We have the fraction 1/8. Well, look, we're dividing by 8. We have the 1/4 point, we're dividing by 4. 3/8, we're dividing by 8. Halfway point for the midpoint, we're dividing by 2. So it looks like, at the very least, the denominator here is the same thing as the denominator of the fraction. Okay, that's pretty handy. Now let's look at what the weights are supposed to be in each of these weighted averages. So this is 1/8. Is there the number 1 in here? There actually is. It's right there. Boop, boop. Implied 1. Likewise, there is an implied 1 right here in front of the x2. And for our fraction 3/8, is there a 3 in our formula? Yeah, this one's obvious, not implied, it's just obvious. There's the 3, here's the 3. Look at our fraction, it's 3/8, it's 1/4, it's 1/8. Here, let's keep going down. This is 1/2, this is 5/8, 5/8, this is 3/4, 3/4. And notice that what's getting the weight, the fractional weight that the part that we're looking for, is the x2 coordinate, 3/4. And then finally 7/8, 7/8. So the next question is like, okay, then what about the x1? What weight does it get? Where is that coming from? Let's go back up here and we're going to try to figure this out. So On the 1/8 one, we can see that our fraction is 1/8, hidden inside of here with the coefficient of x2 being a 1. But where's the 7 coming from? Is there a 7 in this picture right here? If this whole thing is 1, take that back. If the whole thing is 8, and this is 1/8 of that, then that means that everything that's left over must be 7. That's the piece that's left over. You just basically subtract here. All right, and then likewise, the weight that is 3 that's on our x1, it's the piece that's left over. 4 minus 1 gives us a 3. Right. A 5 minus 3 gives us an 8 minus 3 gives us a 5, which is that weight there. We have a 2 minus the 1 gives us also a 1, so it gets a weight also of 1. I think that we have a formula. How are you feeling? There's 3, because 5 from 8 gives us 3 left over. This is going to be a 1 here for this 1. And this one is also going to be a 1. 8 minus 7 gives us 1, and it goes right in front. So do you think you have it? If you think you have it, let's look at this next exercise here. Use your inductive reasoning skills to predict the x value for a point that is 3/5 the distance from point A to point B. So there's no way that you can use an averaging technique to get fifths. You have to have been able to generalize what we just discovered right up here in order to figure out what the 3/5 formula would be. So again, here is our x1, here's our x2. What weighted average is going to give us the coordinate for point P if our fraction is supposed to be 3/5. You try to do it on your own and then check out the next video to see if you did it right.